guys, our next talk. Yeah, our next talk is about cybersecurity for space station with Milenko Starcik. He works for Vision Space System in Darmstadt, from threat modeling to pen testing and R&D stuff. Take it away.
Thank you for the introduction. Thank you. So I think the bar has been set pretty high with the first two talks saying it's not rocket science. So I guess now I have to deliver. But the point of this talk is to show you that it's not rocket science, even if it's rocket science. So cybersecurity across all domains is pretty similar, and we see the same problems as in every other industry, especially when it goes into the OT direction. We have pretty much the same problems. One of the factors is that space systems are pretty expensive by nature. So they are pretty extensive in the development. It takes a long time to build a spacecraft, to launch it, it's very expensive. And then operation requires like trained personnel, the software is specialized. But at the same time, the impact of a failure of one of these systems, for example, weather data, even though yesterday someone said like, yeah, the weather is anyway wrong, the prediction for tomorrow. But for like air traffic management, it's very important to have accurate weather data for like maritime transportation. The weather data actually matters. It's not just about your daily use to know if it will be tomorrow sunny or not. And also in a military context, it's very, very important for your country to know how the weather will be in a certain location. Next is imaging capabilities. Of course, it's nice to have a Google Maps view of the venue here, like you can see where the building is. But at the same time, like high frequency updates of images are actively used in military context as well. So this is very valuable information. For example, like Planet Labs does this. Then we have, of course, telecommunications. You have, of course, like your more traditional services. But then there is now also, for example, for the new iPhone, you can send emergency messages with your iPhone. So what happens if you want to send an emergency message and it's not going through? That's a pretty high risk now with every new telephone out there. There's the new 5G NTN standards coming out, so non-terrestrial networks for 5G. So you will see in the very near future more and more providers like Deutsche Telekom, Starlink, providing you with mobile phone access over satellite. And then we have position, navigation, and timing services, so GNSS, GPS, very well known, again, used by almost everyone, but again, very critical. If it fails, a lot of systems fail that are based on it. Often you don't know that these systems are actually using, for example, GPS to synchronize the timing. So they use GPS for retrieving timing information from the signal as an external source, because maybe you don't have an atomic clock in your infrastructure. But if the GPS fails, you are in real trouble because systems cannot sync anymore. So this is like a high-level overview of how space systems usually work. So you have a ground segment, which is by nature on the ground. It includes the control center, so this is where you operate your satellite, also operate your payload, which is usually separated. So you do the operation of the satellite, and you do the operation of the payload or payloads for larger satellites, often separately, often even done by other companies. You have, of course, launch facilities, so like rockets. Then comes the more obvious part, you have spacecrafts. So one or multiple. Now with like most people know about like SpaceX, for example, deploying like thousands of new satellites. So this can go like from one very specialized system for like scientific missions like the James Webb Space Telescope to very large constellations of satellites. And then you have the user segment. You don't always have a user segment, but if you have it, it could be, for example, your smartphone using a GPS service, or sending an emergency message with your iPhone. So one of the big challenges in satellite systems is that they are usually distributed globally. So you don't have just one antenna talking to your spacecraft, because that would cause many problems. So this is an example from the Galileo system, so the European GPS, so to say. So you have around, I think, currently 29, 30 satellites in orbit. You have ground stations spread across the globe. You have different types of ground stations, actually. You have for mission data, for normal data. All of these are running, globally distributed, usually over like leased lines or something. So there is usually a high quality. And then you have a lot of facilities supporting this, like science centers, operation centers, and so on. When it comes to modeling threats to satellite systems, there's like some very traditional threats. So this has been already demonstrated by a couple of nations, like the US and China and so on, that you can actually shoot down a satellite. That's definitely something that you can do. You can also point a laser at a satellite, and it will have a very bad impact. So this is the more flashy threat. You have, of course, electromagnetic, so classic GPS spoofing, GPS jamming. You can also attack the spacecraft's communication links, so the housekeeping, so if you want to control a spacecraft over RF. And then you have cyber. So the next couple of slides, I want to introduce you a bit to why cyber is a very interesting topic in space system security, because it has its unique properties. So for the different attacks, we have different like subtypes of attacks. This is not a complete list. This is just some of them. So for the kinetic physical attacks, you can destroy a ground station, totally. That's possible. But you can also launch a rocket at a satellite. And yeah, this will also definitely destroy the satellite. But what you can also do was recently demonstrated by China. You can dock to another satellite and drag it. So you can move it somewhere else. So how do you counter that? Then come non-kinetic and electromagnetic threats. So you have what I told you about. So you can do like laser attacks. For example, if you have an optical sensor and you use a high-power laser, you can permanently damage or at least blind it temporarily and cause a denial of service. So if it flies over you, you can point your laser at it, and it will very likely do something. The same you can do with RF, especially interesting for synthetic aperture radar. So you can do like radar imaging of the Earth's surface with satellite. This is currently done. But you can also jam that. We'll show an example how this looks later on. And then, of course, in cyber, you have all the typical cybersecurity attacks that you can imagine. What is now interesting is that attacks on these systems are typically not done by individuals. So this is not your lonely hacker attacking you. This is usually a nation-state actor trying to do something. Of course, you can have a ransomware attack from a ransomware group that suddenly gets your IP address and, I don't know, finds a vulnerability in your system. You can totally also have that in space systems. But the most worrying things are the more sophisticated attacks by nation states, and also the things that recently show up more and more. And for that, what is important to understand is that if you have like a kinetic attack, it's very clear who did it. Like, it's very hard to hide anything you do in space. You cannot shoot up a rocket and think no one notices. Everyone knows. Everyone knows where it was launched. Everyone knows what was hit and what was the result. So you probably don't want to do that if you are not like in an open conflict. Then come the non-kinetic physical threats. So a bit like pointing lasers at spacecraft, still fairly easy to find out because there's like a physical limitation to how you can point a laser. And also the risk of causing permanent damage to the asset is pretty high. So in cyber systems, often the damage is not physical. And with that, somehow policymakers decided this is not as bad. So if you have physical damage, it's bad, and this can cause some escalation. If it's not permanent, yeah, maybe you can give it a try. We see now with, for example, in Estonia and the Baltic, there's a lot of GPS spoofing, GPS jamming, very actively. Also some other regions, where they're trying to find out how far they can go. And then come, of course, the cyber attacks, where you have very limited attribution. You can try to find out some technique patterns. You can, of course, try to work with some IP addresses, but that's like, they will have an infrastructure that you cannot attribute to them, or that will look like someone else. This is like specifically built for that. They will have preparations for that. And for an operator of a spacecraft, it's very difficult to detect it immediately and to do countermeasures. The good thing is it will likely not permanently damage your spacecraft. It will just cause a denial of service of maybe some user equipment, maybe the software will be wiped or something like that, but it will likely not cause any physical damage. But for the attacker, it has a lot of benefits because they can deny it. And they also have a near real-time like damage assessment. They know what they did. Like an attacker is rarely blind when they are performing a cyber attack. Just to briefly touch on the electromagnetic threats, very nice website, by the way, is gpsjam.org, where you can see current GPS jamming worldwide, where there is ADS-B data available. But this also has an impact on ships. AIS systems are impacted as well. It's just visualized with the ADS-B data. So this is over Estonia. And then we see jamming also used against these synthetic aperture radar satellites. So they can create topographic maps and very precisely. So you can track down to a vehicle basically in a three-dimensional point grid. And we see that there is also jamming done. So this is like open source data. You can access the Sentinel hub if you're interested in getting some relatively fresh images from space. And they have different channels and also the Sentinel-1 SAR satellites, for example. And here you can see over Sevastopol in Crimea some active jamming going on these systems. There has been some accidents also for satellite internet, but also satellite TV jamming and spoofing. So satellite TV is something relatively dumb. So it's called a bent pipe. So you send up a signal, and this is distributed down. So if you send up another signal, it will be distributed down, especially in older satellites, like from the Astra satellites, for example. The older ones are just working with that principle. You just need to know the frequency, how it's modulated, you send it up, and it will be distributed. And there have been active attacks where I think it was in the Netherlands, where they overrode some child TV with some propaganda channels. Was pretty wild. So what I want to come to is that all of these things are very nice, but what we see is that the cyber threats are the ones that are dominating all of this. Because there's not just increasing capability, there's also missing awareness of capabilities from APTs. I think many people underestimate how much you can do if you have time and resources. This seems to be like a general misunderstanding from at least my perspective in the space industry, is that many people don't understand what a proficient attacker can do. Like just in the previous talk, they will read all your documentation. And for space systems, we have quite a lot of documentation which tells you how to operate a spacecraft. So they could, for example, use their own ground station and try to command the spacecraft. In addition to that, especially in commercial systems, there's often a shared payload and ground systems operation, so you will have multiple companies connecting into your infrastructure, managing part of it. The lines will not be very clear and definitely not zero trust. The next point is satellite systems are super expensive. It comes cheaper and cheaper, but still, they're insanely expensive. And once you launch a satellite, you want to keep it alive as long as possible, and you will do whatever it takes. Because this is your number one cost, is the satellite. And operating it is expensive, but as long as it's operational, it prints money. this will cause a lot of systems that should not be active to be still active, because the infrastructure is built 20 years ago and they are not upgrading it because it's operational. And of course, the COVID-19 pandemic adds to this. So suddenly you have a VPN access to this legacy OT environment for your satellite operator to operate the spacecraft from home without any multi-factor authentication or something. And this causes problem, and this caused problems. Yeah, in addition, we have a lot of insecurity by design. So satellite systems are pretty difficult to reach. So once you have launched a satellite, it's very difficult to go there and fix something. So you'll often have like some backdoors, some high priority commands you can send, something to do in case something goes wrong. Even if there's even if the communication is encrypted, there will likely be a way to turn off the encryption. Just because otherwise you cannot control the spacecraft, it costed you 2 billion. So what do you want to do? So these are like hard trade-offs, but often, in my opinion, the wrong decision is taken. Then you have a huge threat from insider threats, because the space industry is very contracted out. So you have a very small core stuff in like all the space agencies and operators, but you will have a huge workforce out of that. Because, for example, in Europe, it's how it's organized with the European Space Agency and others. There's a lot of companies like ours who are contracted in, and there's just so many contractors. It's impossible to see how the information flows. It's impossible to track. Then we have, of course, supply chain attacks, not just on hardware, also on the software. And my last point is what I will elaborate a bit more is missing security culture. So there is a huge, I would say, hacking culture in terms of keeping things operational. So if something fails, if there's on spacecrafts, you often have things failing you didn't expect to fail. And they're kind of built to handle this kind of things. And the operators will find a way around to still keep the thing going. But unfortunately, this does not translate to security. So this translates to safety of the thing, but not to the security of the thing. Just an example to show a bit, because it was a pretty public case. So in 2014, there was a Black Hat talk from IOActive on VSAT terminals. So these are end-user terminals that are deployed everywhere around the world. Like you can get one in your backyard, or you can install one on your warship, and you have internet access. And they just got access to a lot of these terminals and tried to find some vulnerabilities, and there was everything like weak passwords, hard-coded credentials, insecure protocols, undocumented protocols, you name it. So yeah, the hope was that something would change. Unfortunately, 4 years later, they did another talk going into the technical details of the weaknesses in the protocols, because previously they just said, okay, weak protocol, and then people said like, yeah, we cannot really do something about it. So they followed up. Next report came out where they showed that they can actually geolocate some of the devices which are deployed in a military context, which is pretty bad. So fast forward another 4 years, some of said terminals were installed on German wind turbines, and suddenly the energy provider Energon faced an outage of like 4,500 of their wind turbines. This was the evening before Russia invaded Ukraine. So the Russians deployed an attack against the Viasat satellite infrastructure and compromised the firmware of roughly 45,000 of these end-user terminals deployed in Ukraine, but also in the region. Germany is obviously part of that region. And so suddenly, 1 year later, we see the vice president and CISO of Viasat on stage at Black Hat with a lady from the NSA giving a nice talk about how they did incident response. And yeah. was quite funny to watch, especially if you track down basically this and you see that actually the things affected by this were known. This was no secret. And this is, again, what I would like to show. This is like an underestimation of effort someone wants to take if they really want to damage something. In this case, it was the Russians. They did an analysis on that. And they basically got into the VPN, jumped through a couple of networks, did a custom DOS attack on an internal protocol, and also deployed this custom malware to the modems via an over-the-air update functionality over the satellites. Yeah. So this is not a singular case. So what I now have are some examples that we produced as part of our research. So to give a bit of an introduction, so the SLE protocol, it's called Space Link Extension, is a protocol that a satellite operator uses to connect their control system for the satellite with a ground station. And this uses TCP, and it has an authentication mechanism. And what we do is we have on the top, we did a simple man-in-the-middle attack. We have on the lower left, we have the server-side application. On the lower right, we have the client-side application. And we wanted to demonstrate that this is inherently insecure. So just because it's like it has an authentication mechanism, but it has a certain lifetime. So if you can steal, again, it's like a bit like a cookie. If you can steal the authentication, you can do whatever you want. You can change the data. You can connect your own mission control system to it. You can change data that is returned from the spacecraft to indicate like a state, whatever you want. Yeah. So all of this is known. This is actually written in the standard. There is a section, like one paragraph, which says, okay, confidentiality, yeah, we don't have. Security, yeah, not really. It's up to the user to implement this. This is written like this in the standard. So we reached out to the standardization organization, and we're like, maybe you could update the standard to make it, like maybe use TLS, I don't know. And they were like, nah, okay. Sorry. Video is always a bit tricky. So, yeah, we went to hunt. So we started our journey with some reviewing protocols, but we found there's a lot of open source software actually out there, which we could test because we don't have any contracts with the companies or organizations operating them or maintaining them. So there is an open bug bounty program for NASA websites, but there is none for their GitHub repositories. Just so no one looks into that. So all of these CVEs we claimed actually. So we found everything you will find in a regular JavaScript application, TypeScript. You will find prototype pollution. You will find XSS, CSRF, you name it. It's just a JavaScript application, but it controls a spacecraft. So yeah, our latest publication was how to crash a spacecraft. So one of the libraries they shared, luckily publicly, is called Cryptolib. So you can end-to-end encrypt the communication between your ground station and your satellite. Unfortunately, there is an out-of-bounds vulnerability in the header of that thing because you have two, it's called security associations in that context. And yeah, you can just go over the boundary and yeah. So the next example I have is from the mission control system. So these are actually is an exploit we wrote chaining 3 of the vulnerabilities. So we have a stored XSS. We have session cookies which are not properly handled. And we have a backend API function which we can call based on that, which allows us to exfiltrate any data on the file system because there's a path traversal, or we can also delete any file on the system. We usually try to implement some exploits chain things or that show the impact. Because from our experience, if you just report an XSS, people are pretty bored and like, yeah, okay, I'll fix that. But showing what the impact can be is usually what catches the attention. So yeah, we'll generate our custom XSS code. So this one involves user interaction, so actually a user has to load the JavaScript, but you will see that they will not see it. So we're listening back for the exfiltrated data with an HTTP server. And then we launch the mission control system. We load a new payload file. And then we have the funny thing about this. So there is like a script viewer. You can actually execute custom scripts written in JavaScript, but it doesn't show the JavaScript if you hide it. So our payload is now actually already executed. And yeah, we got the passwords file. Just an example. So yeah, so the previous mentioned example is here. So we have software running on a spacecraft and inside a ground station. And actually both ends are affected by this vulnerability. So if we either, using the previously mentioned protocol vulnerability, change the data in the header that is sent to the spacecraft to like a value that is out of the norm, or if we send with our own ground station an unauthenticated data package to this spacecraft, the software will crash. So we have on the right is our radio simulator. On the upper left, we have the onboard software running, and on the lower left, we have the ground station running. Okay, so now we change to the encrypted channel on the ground software, and now we'll send a command. So you can see that we got in the onboard software, we got a segmentation fault, and it will now restart. Unfortunately, on the ground system, it's not handled that gracefully, which we'll see in a second. So yeah, we sent our malicious payload packet to the ground station, which could be done, for example, with a software-defined radio, and it will crash the decryption functionality of that piece of software. Yeah, we do all of this to raise a bit awareness also in the space industry, because there's not a huge security culture, as we just try to explain. But there are some good things. There are things moving, often introduced by policymakers or by customers like the military using these systems. So there's first aspect is resilience. So the trend goes to like having multiple orbits, multiple frequency bands, and not just buying from one vendor. So you will buy your user end devices from not just one vendor. You will not just use one satellite network to get your internet connection. You'll have multiple, and the receivers will very likely in the future support multiple. So with standardization, like 5G NTN, for example. For the user segment, we have OSNMA, which is now becoming operational. So this will be an authentication service for GNSS signals. So basically, they send you on a separate channel a fingerprint for GNSS signals, so you cannot be spoofed. Or you can at least detect when someone tries to spoof you, because it's not matching the fingerprint. And for the space segment, like I said earlier, so you can, of course, someone trying to shoot a rocket at you or try to grab your satellite, so they are adding more maneuverability to the systems. Same goes for electronic warfare, so they try to be more resilient to jamming attacks, also using like laser communications, which is a lot more directed and a lot more difficult to intercept or to attack, and active sensor protection systems. What we see is an increased use of cloud services, also like the big providers like Microsoft and also Amazon. They have their own ground station network, which you can access actually as like an AWS ground station service. So they have like sites around the world where you can subscribe to. This is like this ground station as a service concept. There's a couple of players out there. But this comes, of course, always with a risk. So if you are relying on one of them, yeah, you better make sure that you do it properly. Another thing which was previously burned into the spacecraft is the software. Now with more powerful onboard computers, it actually becomes more configurable. And now often, actually, users can run sandboxed applications on spacecrafts directly. So this is used, for example, for edge processing. So if you take an image of the surface of Earth and you have cloud coverage above 80%, you might want to discard it. So there is like image processing going on board and all these custom applications, which again introduces some risk because now you have suddenly software from someone else running on a spacecraft. Yeah, and then we have the quantum and crypto things, which are slowly coming. So especially for the governmental side of things, they are very interested in post-quantum, quantum cryptography, crypto agility, so the buzzwords. But this is far from reality. So this is in the very early stages. Yeah, so that's it basically. Any questions? Yeah. No. We didn't test Starlink. I know there's some stuff done on hardware hacking and so on in Starlink, but we don't have any relationship to SpaceX or Starlink.
So I have a question about Vision Space. So do you do consulting for the European Space agencies or like companies surrounding that? And could you tell a little bit more about that?
Yeah,
So what projects you're doing?
Yeah. So yeah, we do consulting services for the European Space Agency, for EUMETSAT, which is also located in Darmstadt, which is the organization for meteorological satellites. So they're operating all the weather spacecraft for Europe, which is then processed here in Offenbach. We do European projects, so like commission projects. We do work with most of the large players in the space industry in Europe around that. So there's like a handful of larger companies doing that. And yeah, we work with most of them. Oh, sorry? Yeah, so since this is like public knowledge, we are in a contract, for example, for building a SOC for the European Space Agency currently, together with Leonardo and REA. Yeah,
Okay. Yeah, one question.
Yeah.
I think the upcoming NIS2 regulation also includes spacecraft stuff. And I've learned that, I mean, spacecrafts are super expensive. They have to run for 30, 40 years, and they are very hard to replace. Do you think there is a huge non-compliance risk in the space industry, or are they kind of prepared to upgrade those satellites and ground stations and everything? Because that really sounds like the ultimate legacy systems.
Yeah, I mean, for example, in Germany with the BSI Grundschutz, also for Raumfahrtsysteme, there are some new standards being rolled out. The thing is with the space industry, they're very good at meeting requirements. So like requirements engineering is half of the business. So they will usually be compliant in a way. But it usually doesn't mean that they're safe.
I think the gentleman at the corner.
Yeah. I mean, of course, like you will if you like do RF, if you mean like RF hacking, then you will face your local entities because the ITU delegates that down to the nations. So in Germany, this will be the how they're called, Bundesnetzagentur. So you will do like an unauthorized transmission in the frequency band that you're not allowed to use. And then the satellite provider will file a complaint against your national authority and they will start an investigation. And yeah, and then things will slowly go.
Thanks for the talk. There's a lot of attacks going on in the internet as we know it. There's a lot of pew-pew maps, as you know. Are there maps like for attacks into space systems? How much is going on there? What's your estimation? Is this...
So the attacks against space systems, so previously these systems were very isolated. And because of that, they were also kind of secure, but it was often like counting on the parameter. So it was a lot parameter security. So you just had like a separate physical network rolled out, like with leased lines across the globe, like huge costs, but it was kind of secure. Now this is changing to more cloud providers. You are integrating some AI things here and there, and it becomes fuzzy. There is very little known publicly about most attacks, I would say. Like only very few things make it to the news. Like if like a stock traded company is affected, then they will have to disclose it, or also if like local legislation requires them to report it and also to disclose it, which is rare. So it's a very gray field. Like it's very difficult to see because there is not much made public because it will impact like your integrity. So people will not talk about it. No one would say anything about it, if anyhow possible. For example, with the European Space Agency, they are in a special position. They're not governed by national law or European law. They stand outside of the legal system. They have their own legal system. No, they have their own requirements, but they're like an organization similar to like the United Nations. You cannot sue the United Nations. Good luck trying that. And good luck trying to get a disclosure from European Space Agency, for example.
Any more questions, guys?
Obviously, that topic is really, really interesting. It's going to be more and more, I guess, commented in the future. But can you give an example of cyber attack against satellites or spacecraft that really impacted the nation? I mean, obviously, if attack against Starlink is being successfully executed, that's going to have a big impact on normal consumers along with military, because we know that Starlink is actively used in Russian-Ukrainian war. But can you give any other example that, you know?
So this seems to be like still a bit of a no-touch topic. So it seems like they are still staying away, referring from attacking the spacecrafts themselves. I don't know of an attack where actually... there have been some reports of some old NASA meteorological satellites being commanded by someone unauthorized, but it was never done in a way that it would compromise the mission on a long term. It never had a lasting impact. This seems to be something that is currently still out out of what you can do. So, but yeah, like I said, like with more software running on spacecrafts, previously these were very like electronic physical systems. Now with them being more modular, more programmable, it can very well happen that we will see some like malware deployed on a satellite. Could happen because often they're just running Linux nowadays. So.
Do we have any more? Oh, okay.
Thanks for your talk. I'm just wondering about ownership. So if your satellite gets pawned and the attacker has full control of it, when you have virtual machines, websites, when your car is stolen, it's still something that you can grab, which the police can shut down, a server you can switch off. How is it regulated in space? As you said, there are various attacks where you can like shoot the satellite down. There's a lot of collateral damage that could occur. Are there any regulations or discussions about how the process would work there if somebody loses control of their satellite?
Not really. So there's like the Treaty of the Peaceful Use of Outer Space by the United Nations, but that's more like guidelines. Yeah, so I mean, the satellites belongs to the legal system of the country that launched it, and that's as much as I can say about that. So it will depend on the nation owning the spacecraft.
Do we have any more other questions? Wonderful.
Hi, so first of all, thank you for the very nice presentation. It's a very nice topic, in my opinion. What I just want to ask out of curiosity is, do you also have done much cooperations like with central intelligence agencies or like with the military, since they also operate with using like satellites? As I know, I think in Germany there's this big project like called SIGINT. I think it is used by the BND.
I'm not sure, can you repeat the question? I'm not sure what the actual question is.
Also, my basic question was like, is there also like a cooperation with the military or the central intelligence agencies like the BND, for example?
Yeah, so like I just said, so the BSI, for example, they are now rolling out more policies also for operating spacecrafts and for companies contracting in the critical infrastructure. So it's now treated as a critical infrastructure domain, and also space is a warfighting domain. So like the German army now has a space force as well. So there's a closer cooperation now between like critical infrastructure providers and cyber defense operations. So this is really coming closer and closer together. The cyber defense and critical infrastructure, and space is part of critical infrastructure, but also energy, transportation. There's more and more cooperation, like in terms of like NATO, for example, does a lot of things there.
All right, thank you.
So any more other questions?
Right.
Okay, thank you so much,
Thank you.
Milenko.